Hello and welcome. In today's lecture of WT, we will be knowing about casting and different aspects of casting. What is the casting process and how this process takes place, and what are the others features and parameters and factors that are involved in the casting will be introduced today. So, as we have earlier studied, casting is the process uh, at the introduction of the at the starting of the introduction, we talked about the casting process. So, uh, this is the casting process. We can see casting is a process in which the metal is melt above melting temperature. And when this solid metal comes into the liquid form, it is then poured into a cavity known as mold. Then the solidification time is given, and when this molten metal comes into solidified component, it is the mold is broken and the part is taken out. Mostly the mold is broken and sometimes it is not broken. So we have earlier known about the single and multiple mold casting. In single use of mold, the mold is broken out, and in the multiple use mold, the mold is not broken and mold is given an opening where from we can take the part out. So this is the casting process. We can see there is a ladle or bucket in from which the molten metal is poured into a cavity known as mold. This cavity is known as mold. This part is known as mold ladle. This is the bucket in which molten metal is taken from the furnace. So before starting, we will be knowing a few fundamentals, like we have books Kalpagyan, Bothroyd, Design for Die Casting, Fleming's Heat Flow and Solidification, Delquist, LC of Casting. These are basically books that are referred, but my notes are enough for this process, and the whole casting is given there. So now come to the second slide, casting methods. You will be knowing what are different types of casting methods. These are the figures that are given. We'll be discussing later on every type of casting in detail. First of all, we need to know what is the casting and what processes takes place, how this process takes place. So this is the sand casting, and you can see a number of parts or components. This is casting, basically the oldest method of making part of mechanical manufacturing. So earlier people used to, at the starting of the manufacturing, people used to melt the molten metal and then pour into a cavity and then giving shape of their desire. So desired shape and size was given by application of this casting. In casting, the temperature is kept above melting temperature so that the solid metal is converted into a liquid metal, and then this then the solidification time is given, and similarly the part is manufactured. So in this process, pressure or force is not applied except one case. One case is exceptional, that is known as pressure die casting. Otherwise, the temperature, the pressure is not applied at all. In this process, only only temperature is applied, and that too above melting temperature. So casting is a process that basically uses heat normally, except one, and that is exception one. So this is called pressure die casting. Otherwise, all the other casting processes are limited with heat only. So these are the parts that are produced by the casting, sand casting, mechanical drawing of parts, core pattern, core prints, gates. These are the various devices that are basically used for casting process. We'll know one by one. Sand casting, you can see there is a one mold and ladle. cavity. The molten metal is being poured into ladle casting. This is the sand casting mold features. And the most important picture is this, and we'll discuss this part, and we'll discuss. Yes, this is the schematic of illustration. This is the most important part, and this is the most important figure of casting. So in this casting, we'll be knowing, in this figure, we'll be knowing what are the different components and different parts that are given on the in this figure, and how this casting takes place. So first we should know, this is the this is the casting. This is base. This is the casting in for which we have to. This is the casting or the part that we have to make. So this is the gate. This is the riser, side riser. Then this is screw, pouring cup, top riser. We'll talk about one by one. We'll talk about every component, in all the aspects in detail. Before that, we must be knowing casting is one of the oldest manufacturing processes. So steps, first of all, we have to make the cavity, we have to make the mold, then we have to melt the material, and when this material is molten, we have to pour this liquid metal into the cavity, and then we have to give solidification time, then only we'll be able to take out the, after solidification time, then only we'll be taking out the part. So initially we need to prepare the molds, then melting and pouring of the liquefied metal, solidification, further cooling to room temperature. Then only we would be able to take out the part. So this is after taking out the part, we uh, inspect and find the defects. Advantages, what are the advantages? Molten metal can flow into every small section so that intricate shapes can be made by this process. First thing is, this process is very easy process, and there is no need of skill worker or anything else. It can be done by anybody. Number one. Uh, Number two is that complicated shapes can also be made. Typical shapes can also be made. Number three, it needs little infrastructure at low cost. A production can be done, and we will see that most of the parts are made up of casting. So casting is the process that has capability of producing almost all types of shapes and sizes. So this is commonly applied, and more than that, it can be applied to any metal. So it has advantage that it can be applied to any metal, and any shape can be casted, any complicated shape can be casted by this process. So this process is widely applicable to the in manufacturing sector. So these are the benefits or advantages of casting. And then last one is size and weight of the product is not limitation for the casting process. That means any size and any shape can be made by casting process. This process is very much cost effective, and it does not need a heavy setup and a heavy in investment. So casting is the process that can be applied, and most of the parts of manufacturing, 70-80% parts are made. A rough approximation says that up to say 70 or 80% parts are made by casting process, and other part rather it is preferred over other manufacturing processes. So few limitations are also there. One is limitations. First limitation or disadvantage is that dimensional accuracy and surface finish are not up to mark, and they are needed to be further worked. So dimensional accuracy and surface finish is not good. So these are basically disadvantages of the casting, and Second is that it is a labor intensive process, and temperature is high, melting temperature is very high, so the worker has to come in touch with it with that temperature, and it is labor intensive. That means it needs hard work by the human being. And also dimensional accuracy surface parts, and above and above uh, poor mechanical properties are also there. Poor mechanical properties or very good mechanical properties are not achieved in casted parts. So, like brittleness is very high in casted parts, apart from other processes. So, this is the schematic that we'll discuss today. This is the typical sand mold. Mold is the cavity or the cavity or the device in which we have to put the molten metal. So first, this is we'll start from scratch, and we'll see we have a molding flask. First of all, we take a molding flask. Molding flask is a cylindrical shell open from both the sides. Cylindrical shell open from both the sides. And if this cylindrical shell shape, if this cylindrical shell has two parts, normally it has two parts. So top part is called cope and bottom part is called drag. For top part is called cope and bottom part is called drag. Then there is parting line. That means the upper portion is separate and lower portion is separate. And this is locating pins. Locating pins are normally used to align the top and bottom portion. So first of all, molding flask is taken, and there is a bottom board. Since it is hollow, the through hole is there. So if we have to put anything in it, we need a board. So there is a sanding, there is a bottom board. That bottom board is kept under the flask, under the molding flask. So first what we do, we take drag in reverse direction. We take drag, lower part we take, and we keep it in, we keep upside down. So when we keep upside down, this portion, the locating pin portion is low beneath. And then what we do, we fill molding sand in this. This is the molding sand. This is the molding sand. Molding sand is filled into the drag, inverted drag part, that is lower part of the flask. So when and the sand is filled, when this sand is completely filled, we reverse the molding flask, we reverse the drag, so that drag's upper portion comes upside. And what we need to do, we need to take the, and we then put a pattern in this cavity, in this sand, in this molding flask. What is cavity? What is pattern? Pattern is basically duplicate or replica of the part that is to be produced. So molding sand, we put the pattern, and then we keep the cope over it, and then we align it. Then we, by aligning and by locking the locating pins, we align. So this top portion of and lower portion of this molding flask, cope and drag, is perfectly aligned. Then the pattern is kept. This is the pattern, that pattern is kept. And when the pattern is kept, then two or three devices again are given. One is this sprue, and then this is sprue, then this is runner, and sorry, this is pouring basin cup, this is a sprue, and then this is runner, and then this is the riser, and then vent is given. So these are the other parts that are given. So once we place pouring basin, we place runner, we place part, we place core, we place riser, we again start, and then vent is given. And after these parts are given, after these devices are placed in the cylindrical shell, we again start filling molding sand in this. Then it takes complete sand filling, and when this complete sand filling is done, what we do, we start patting, we start solidifying the molding sand. If it is not solidify, it will collapse and when the casting is done. So we hammer this and we pat this so that the compacting is done, so that the molding sand is completely stick together and form a complete body. And then at the time of making mold, the at the time of filling the sand, the mold is the sand is slightly sticky and slightly wet. So the solidification time is done, cooling time is done. When the cooling is done, after cooling, we open the locating pins, we open the locking pins, and then we take the upper part upside and lower part separate. After we take the lower part and upper part, we remove the upper part, we remove the pattern, and we remove the pouring basin, and we remove the sprue, and we remove the riser, and we remove the rivet. So all these we remove and only remains in the molding sand, in the molding flask is sand. So this sand is left, solidified sand is left, and all other parts are removed. And the parts where from the space where from these parts have been removed, a cavity is created. A cavity is created since pouring basin is removed, screw is removed, then runner is removed, cavity is removed, core side is removed, cope is removed, then riser is removed. All these parts, all these devices are removed, and there remains one. There remains cavity, and this cavity is used for molting the metal, for pouring the metal. Then what we do? We lock up. We again relocate the locking pins, and then we can see in this picture is more clear. So we start pouring molten metal from here. When the molten metal comes inside this is the lower part or horizontal part, horizontal channel that basically keeps molten, that takes molten metal from the pouring basin. This is pouring basin, top portion, and this is screw, vertical part that carries the molten metal. Then this comes through the runner, and then this enters into a cavity of which the part is to be produced. This is the vent where from the heat has to scope, because on solidification the heat will be evolved. So this vent is given for escaping of heat, and the molten metal comes here, comes here, comes here, and start rising from here. So this is the riser. I'll tell what is the function of riser later on. So initially we will pour the liquid from here, and then this metal, liquid metal comes here to here, here to here, and then it takes place. There is this mold cavity. This takes place of this cavity and rises here. So when the molten metal is poured and molten metal is completely fills the mold, so we can see when the metal is returning back from the riser, we stop the pouring, and when pouring is done, completely done, then we leave the mold for quite some time. In that, for is that some time is defined for every metal. How much time will it take to solidify? It is already mentioned. We know how much time the molten metal is going to take place. So this is basic. We can see this is the top riser, this is the casting, this is the gate, this is the pouring cup. The molten metal is poured through this pouring cup, and this is the sprue. Then this comes from here, then riser is there, then gate is the place where from the molten metal enters into the cavity, the main cavity. This is the main casting. Actually this part is to be produced, and this everything is additional. Only this part is to be produced. So given the nature of the casting, these parts are projections or extra metal that has been solidified with the part. So when the cooling is done, these parts are cut. This cut from here and from here. So top riser and side riser along with pouring cup, screw, and runner and gate are again melted. So these are again used. These are again used for the prepare for reuse, and part is taken out. This is the whole part that is taken out. This is part produced by casting, and then surface finish, etc., machining, etc., is done on this part, and this part is basically we have to produce, we have to utilize. Okay, so this was the complete process of how casting takes place. So further we'll be studying what types of casting processes are there and how these processes takes place, and what are the other devices that are associated with the casting processes. I hope everything is clear now for about the casting. Still, if some points may not be clear, so you may get in touch with me personally. You have my phone number, otherwise you may ask me. I will give you phone number right at the, you can see my number. I'm going to give you my phone number in this. This is this is 906936. So you can get in touch me if you have clarifications, or you need any clarification, or you want to understand any part that is not clear to you. So this was about basic introduction and basic about casting. Hope you have got the view. Okay, so bye for now.